Kia ora, good evening. Welcome to one more session of Code Night New Zealand. And today, April 21st, Easter Monday, and well, we're gonna have a session. Why not? Here in New Zealand, we're just coming like off some holiday, and I actually only realized about the session later that we were like on a holiday, but it's still like it's always time like to learn. And tonight, we're going to be exploring an AI agentic framework. Not sure if you're aware, but this is called Autogen Agent Framework. It's one of those leading AI agentic frameworks, and it's being, let's say, with Microsoft since last year. So it's being like getting like becoming popular, and there's been a lot of going on with the framework. And tonight I'm going to be your host and also your guest. So I'm basically introducing you guys to this framework. This is a session I shared with the global AI last month. But tonight we have 1 hour, and then we're gonna have like a lot of time to explore and do some coding. I guess like it's going to be fun, and hope you enjoy. So if you're coming like in here for the first time, uh, so let me just share like my screen here and bring like the slides. Cool. So if you don't know me, my name is Marcel Medina. I'm a software developer, Azure specialist. As you can see here, like I'm also like a Microsoft MVP, currently working as a consultant at Arinco. And this is my blog, tech.playgokids.com. That's my QR code that leads you to my blog. In general, like blogging, it's been a little bit challenging. Sharing sessions being like a little bit more interesting because there are always new things. While blogging, it takes like a little bit more time, but I'll get there. But yeah, now and then, like I tend to post something, but yeah, it's good just to get to share what you learn in through work and interesting things. So yeah, I invite you to be in touch. And also, I'd like to mention about the Coding Nights user group that we are a community group of developers. We love coding. We follow best practices on software development languages and technologies. In general, the content that we get to share here is more aligned with the Microsoft stack. We're always open to any sort of technologies. And that's our purpose in here to enable developers with practical knowledge to excel and launch their careers. And as you can see, we're part of AzureTire.com. We are a group of enthusiasts where we get to share like the latest and greatest under the cloud native space. We're sponsored by .NETFoundation.org, the entity that looks after the different open source .NET projects, and JetBrains, software tooling for developers. And yeah, with no further ado, I'm just going to get started. And we're going to have like a little bit of like an intro and then demos. Really, we're going to explore the framework, how it works, and what you can do with that. So starting, right? Um, we're what are AI agents? So well, they're like the agents concepts, but what about AI agents? If you look like at those AI agents, they are basically systems that enable large language models, LLMs, to perform actions by extending its capabilities through access to tools and access to knowledge. What does it mean? So, well, when you look like those large language models, they don't have, well, through like a ChatGPT, for example, you can simply put like a query and get a response out of that. When you look at those agents, they're kind of autonomous, right? And they have like full understanding of like their environments, what's available to them, like these tools. Tools are basically functions that can enable you to make API queries that can have some specific logic for solving a particular problem. And knowledge could be associated to, for example, the information that's available on a database. Something like if you look at those, I'd say classic AI agents, but the travel agents, right, where they know about your user preferences, right, things like that. So through like this sort of knowledge, agents can better serve you. So that's like what we have in here, like with the AI agents, right, where the LLM is the main player, and you have like these extensions to enable like the agent to perform those actions and make decisions. When to use AI agents? All right, that's a good question. So what they're good for? Open-ended problems, problems you have where you have multiple solutions or no clear answer. So complex problems. Uh, those AI agents are pretty good, like those multi-stepped processes. So basically, take like this large, big problem and breaking down into smaller pieces. So like through an iteration process of evaluation, you get to refine and get, or those agents can get to refine and find like an answer. And AI agents also like are good, like they can like improve through like knowledge. They can improve over time. So with knowledge and through like a feedback iteration, feedback loop, you can basically provide or have um, uh, that sort of response that matches or helps resolving problems more quickly. So with time, you can like increase the sort of knowledge, and you're basically improving the answers like with those agents. And then comes to Autogen, right? So open source framework for building AI agents and applications. So this framework was created like by Microsoft. They call like the department is the Microsoft Research's AI Frontiers Lab. So like the purpose, the main use case for Autogen is for like prototyping and experimenting with agents. So you can get like a more, or it's easier to use when you compare like with other frameworks, semantic kernel, for example. You're going to see that they simplify a lot, right? So behind the scenes, they're doing the heavy lift. With that, you focus more on what you're trying to achieve, right? Rather than the technical implementation itself. And that helps. That helps a lot, right? Because rather than focusing on like technical concerns, you're just basically trying to achieve the results with and solve problems. That's it. When you look at those agents, right? So they're basically actors. So agents leverage like this actor model, which is building block. Let's say it's a building block that can process multiple tasks simultaneously. And with that, it can act or react, right? Or depending on messages like that it receives, because it can communicate with other actors. And that's the purpose with those agents, right? So if you just like revert like actors with agents, that's what they are. So they can communicate to each other. They can like you can bring some sort of a specific problem and break it down onto those agents. They are specialized agents and can resolve problems uniquely, right? And with an expertise that you can configure it, right, through system prompts, basically. And what's nice about Autogem is that it brings like this environment or this framework, which is event driven for use like targeting distributed agentic applications, right? So you have like this sort of in process uh, execution, or you can distribute that into other like applications, right? So I think like the framework itself it's robust, right, and allows you to have the sort of even like the messaging, how like it communicates between agents in a way that you have full control, and we're gonna check that some with the demos. And well, they basically use for as a conversational agents. There are different patterns, emerging patterns, to be honest. Where like in general you're gonna see that you have like a human in the loop or a human coming and providing like a question, coming with questions, agents that get to answer, but then you're gonna see that there's some sort of orchestration, orchestrator, kind of like a agent that's a manager that can delegate um, requests, right? Here I'm just bringing some scenarios in here, like hierarchical chats, but there are lots, right? My intent is not to go through all these like patterns. There are emerging patterns, as I said, but with the AutoGen, they have predefined patterns that you can use. And I'm gonna bring some examples on the codes. And AutoGen. So they're composed by different parts, like Magento 1 CLI, which is a kind of a console-based agent that allows you to handle file and web-based tasks. When you say file, like disk, or you're going through your disk and making decisions over files, or web, going wildly to the web and doing data scraping on, on your behalf, right? So just the sort of automation that does miracles. There's also like AutoGen Studio, which is an app that used like for low code experimentations. Agent Chat, which is this programming framework that brings like this whole sort of libraries for us to code against. AutoGen Core, which contains a more like this event-driven programming framework, right? So the agent chat is more like an abstraction on top of core. And you can have extensions. So there are like some examples where there's Docker, like you can run code onto Docker containers. So well, Docker has created an extension for that. So there are lots really that you can do with the platform. When you're organizing in a hierarchical view, we can see that Magentic 1, AutoGen Studio kind of use agentic chat that wraps up all its functionalities of core, and extensions being available for agent agent chats and also core. This is like the official image from AutoGen, where you can see Magentic 1 as an app on top. Extensions coming down like with the agent AutoGen framework, agent chats on top of core. On the left side, you can see AutoGen Studio, right? As I mentioned about this app for low code platform for prototyping. There's also like on the top left, you have like this AutoGen Bench, which is a tool that allows you to do benchmark and check like the performance of um, evaluations really of what's happening, right? Why it's taking like that long. So you can see like the details of what's happening within AutoGen in the decision framework that's implemented in there. And we're gonna go to demos. That's it. We have like time for exploring things. Uh, Before like I jump to demos, or just recording here, those are the QR codes if you want to explore later on. One thing like to mention is that well, we're gonna be raffling some JetBrains licenses in the end, so stick around. Let me just share like my screen here, and I'm gonna bring the code for that. So this one. Okay. One of the things that I didn't bring, let me see. Can I zoom in? Probably not. Let me just zoom in a little bit more. Okay, I think this one is okay-ish. Right. I still like want to bring like one more thing. So if I need to zoom, I have like the details available and I can do that. Just bear with me. I'm just opening another window here. Okay, let's see. Cool. Yeah, I have the zoom available. That's all good. Let's see here. Well, we're gonna come. This is the repository that we have the patterns. They are more complex because what happens in here is that those patterns they are leveraging the Autogen core, right? So as I mentioned, there is Autogen chat, which is this abstraction on top of core. And here we have the core. And what we're gonna notice with the core is that we have messages. Even like the implementation. So this is a Python notebook. So I'm just coming here. You're gonna see that, um, well, so this is all running Python, right? Just because the latest libraries come in Python first and .NET later. I was experimenting with .NET, so there are some limitations at this stage. So that's why we're seeing Python. And with Python notebooks, well, they are very easy to use, right? Providing you have like installed the Python, or, well, I would say the libraries, and you can simply run it, and you can see like the behavior of the application, and through like those arrows you see on Visual Studio codes that they're being triggered. As you can see here, right? So I use like Python 3.12.7. And this example it was extracted from Autogen, and I'm basically using their codes. Uh, it's just I brought like onto a separate repository. From what you can see here, like we're exploring like concurrent agents. So it's going to show how it works. Imports, right? I think like for now that's what you need to know. This is how like we define classes. This is just like a task that has like an identifier and a task response has an identifier and a result of type strings. That's it. So it's just like using that for wrapping how we send messages and how we receive messages. If you look in here, these are default subscription. Uh, on later samples, you're going to see that this can change a little bit. But look at this. So we have like these rooted agents, and this is part of the core, right? So if you look, so this is part of the core in here. With the core libraries, we have some implementations of those like the baselines. And there is a creation here of an agent called processor. That's it. And what it does is that when it receives a task, it prints what it is. So it prints like the description, the task number, starting task. There is a sleep of like 2 second slip, and then it finishes. It just prints things. This is an agent where we have no AI at all. We don't have any LLM. We're simply like wrapping execution of a process into Autogen, right? So you don't need to have LLM. Why this is good? I find it good, right? Because you could have like this sort of range or creation of multiple agents that can leverage LLM for resolving problems. But for example, if you want to create an agent to send emails, well, we don't need to hook to a LLM to send emails. You could basically just wait like for this task on a task that's assigned to it, send an email. That's it. So you could have like this assist ecosystem of agents running simultaneously, right? Leveraging Autogen. And that's pretty good because then you have like freedom to use the same sort of actor model to and get like actors, those agents to work together. We're gonna see here, okay, we have like a single threaded agent runtime. This is kind of your hook or allow things to run. And then we need to register agents. Just a label, agent one, agent two, that's it. But this is the agents. We're defining that, okay, this is a processor for agent one, processor, agent two. It only does that. It only knows how to do this, just to print what it receives. And then like you start the runtime and you publish the message. You can see here like the default topic, right? So this is, so if you look, uh, well, a sensible default for the topic ID. And that's behind the scenes, we have a queue. That's a queue. So that is default subscription. So as I said, like you work with like event-driven um, implementation through the use of messages. All right. So what's going to do? We're going to publish a message. Things are going to happen. Like, well, we have like two agents. Both are going to respond to that because they are listening to the same default topic, which is this one. There's a so what the processor is doing, subscribing to again, right? So let me just trigger. Generally, this is fast, but I've been doing this. I think like I didn't load up front, so fingers crossed. Well, 14 seconds. The other execution should be like a second or so. But anyways, so like then we're just loading. I'm just loading. In here, that's when things are gonna start. Right. So you can see that it started, it printed nothing. Agent one, agent two. There was a 2-second period, and then it finished one, finished two. As simple as that. Okay. So yeah, so far so good. So you could see that um, how it works, and then we can bring LLMs on top of that. But we can even associate or define a sequence of how those agents get to work. So let's see like this one, other one, concurrent agent two. Yeah, have a look at the code, right? Because same as before, same classes, task response. But in here is a string of task results. But what it does is that we associate this name to as a topic, as a queue. So we have the task results being there as a queue. And where it's being used. So if you look in here, there is like this, well, now we have like urgent processor and normal processor. They also print the message, but what the urgent does is that it awaits for 1 second while the normal takes a 3 second sleep, right? So it's just lower. But in the end, what it does is that it creates a response, which is this one is a results by an urgent processor, and the one down is results by a normal processor. Just a string. It publishes to a queue. That's it. It doesn't do uh, anything different than that, and there are no secrets behind. Similar as before, now we're registering, well, two agents with like two implementations, one for the urgent processor and the normal processor. And use strings. That's it. But when we're publishing here in the end, well, we're kind of first we're registering and then we're starting. So we're gonna trigger. The first one is going to go to the type normal, and the other one is going to go to the type urgent. The type is defined here. Okay. This is the first type subscription topic. urgent. The other one, normal. So both agents are listening to those topics, right? And when we push like a message to each separate topic, they're going to answer. And then, oh, you're gonna see that. Wow, 15 seconds. Come on. Oh, in general, it's much faster than that. Anyways, I should have loaded this one before, but yeah, we're gonna do it as is. So I'm just loading, right? And this is when we're going to trigger. Let's trigger that. Normal processor, urgent. So the normal took like 3 second periods, and it finished as the last because yeah, urgent takes like only 1 second. But it did that. So we sent like two messages separately to different topics. I'm gonna save this. And now let's extend a little bit, going like a little bit further. Um, so let's see. Same thing in here, same classes in here. Not that different as before. We had like the same changes in here in the implementation, but we have a way of looking in more details on what happens after they we pull like the message. In the previous ones, we're just simply okay, push the message later on. Well, first we receive, we trigger, but then what we publish, we're we're doing nothing really. But in here we're registering the urgent processor, normal processor, but we have like a queue in here, like or we're using a sync queue, and we're creating a queue. And we have like this method that puts messages onto the queue called collect results. And when you look in here, what it does is that this closure agent that, well, has like this agent, which is a name, the closure agent type. We have like these methods, so it knows that's the tool, right? So remember, agents leverage tools. This is a tool, which is a function. We're basically collecting the message and putting onto a queue. And what it does is that, what's the topic? Task results topic type, which is the one that we defined here, task results. But in here, it's putting that, the message onto the topic. And what we're doing here is that, well, we're not doing much different. So like we're just pushing, triggering those agents for the topic normal and topic urgent. And in here, in the end, we're gonna watch like the results because those agents, they're going to push a message to the queue, and here we're printing those. But it's interesting that what it allows us to do afterwards, because it means that you have that queue. If you say, if you want to have define an agent to perform an action after something has happened, you could hook like the other agents to that topic and execute whatever you want. So let's just like load up that. This one is going to trigger things. So it's going to publish. Uh, let's wait. So it finished, right? Like similar as before. So we have like the normal processor getting triggered, a 3 second period, and then it finishes later than urgent. The urgent takes 1 second. And here we're gonna print the results. All right, so the first agent, well, first one to execute or send was the urgent. It put like the tasks and the results onto the queue, and then later the normal went there and pushed like the finished, right? It was the last to push in here. So we're seeing here that the messages are being dropped to those queues. And we could do something like, I'm going to jump to something more, it's still simple, but you're going to see that we can connect agents. And behind the scenes, see like how you can start like this sort of creating workflows, right? So in here comes with the power of Autogen. You can create those flows where you create a task and you put like a message. Those agents can execute those tasks based on what they're listening to. Uh, Similar here, like an import is just a basic loading up like those models. But in here, I'm bringing LLM. So you can see that we have like the open Azure OpenAI chat completion client, right? So there are like libraries for that. And then I'm using the bearer token. So I don't have like hard-coded secrets at all. I'm just using my credentials. But let's load up this one. I'm loading the environment variables, which, well, I don't, as I said, I don't have any secrets in here. I just have like my service name. That's it. I'm just loading that up. In here, I'm getting like an access token, and I'm leveraging GPT 4.0. And my secrets here, like just the service name. And I'm taking like the GPT 4.0 for this task. Let me load that up. And from here, I have like this message, which is a class that's going to wrap some sort of content. It's interesting that uh, what's happening here, right? So this, what this agent does is a sequential workflow, but these agents, what they do, they're going to be targeting a particular product. And from what you give them, they're going to look, okay, the concept extractor. It's going to, you're going to say, this is the object. I'm giving you the object, extract the qualities of the object, and transform into a marketing um, um, sample or where you can just advertise to users, right? So that's why we have like a writer, format proof, and the user. So kind of like here, just labels, really, just like strings. But when we come to the agents, so similar as before, type subscription, this is our topic. So the names in here are the topics, okay? Topic. So they're going to be listening to those topics. What's different in here is that you can see that there is a constructor, which is the init. It is receiving a model client, which is the chat completion client. So we're hooking in here the LLM, and we have a prompt. So for like this one, the concept extractor, it says you're a marketing analyst. Given the product description, identify. So we're giving them like giving it a task, key features, target audience, unique selling points. So yeah, so the agent knows what it can do. We call like this one as a system message. That's the prompt we provide to the agent. And here, what happens is that okay, it takes the message, it passes through the client, and then we get a result. From that result, we do assertion if like okay, it matches what we're expecting here. There's like a specific implementation is instance. Those are part of the core libraries, right, Autogen. But it only prints things in here and it publishes to the writer topic. So it's just a sequence in here. So I'm doing my thing, throwing over the fence. The other is going to pick that up, do whatever needs to be done. Well, here you can see the prompt. They're like your marketing copywriter, given a block of text describing features, audience, USPs. So like compose a compelling marketing copy or newsletter, blah, blah, blah. So it's just, okay, putting into words, right, what the other agents provided. And it's doing the same. Take the message, pass to the LLM, take the results, print it, give it to the next. Format proof. You can see here, like you're an editor, giving the drafts, correct grammar, improve clarity, make it polish. So yeah, the other agents just like improving. It's doing only that. Take the message, pass to the LLM, take the response, print it, give to the other one, to the user. Interesting here that the user, oh, there is like a constructor, but where's the LLM? There's no LLM at all. It only prints. So the user here doesn't do anything. It's just take what's given and print it. So yeah, it's an agent without LLM. And then we're registering, doing similar as before. Those agents, we need to register, associate to the agent, passing the topics, right? So each one is going to be listening to a particular topic. And then we can start. But first, we need to send the message to the first topic, the beginning one. And we're saying an eco-friendly stainless steel water bottle that keeps drinks cold for 24 hours. And well, that's it. So in here we're bringing LLM. So opening here, the classes, variables, loading agents, nothing's being executed. In here, it's still loading agents. In here, I'm registering the agents, and this is now going to trigger things. Okay, well, let's see. All right. So hopefully we start getting like some outputs. We should have those outputs in here. Well, because of the underlying implementation or how the agents get to run, and you just give like them a task. But what happens behind the scenes, Autogen automatically hand those queries to the LLM, and with that, it kind of abstracts the complex, even like with the core, right? Because if you compare like with other frameworks like semantic kernel, oh, that's new. But like what happens like behind the scenes with semantic kernel where you have more control. In here, that's not the case. Like things are happening behind the scenes. That's why like this is leveraged for researching purposes. Oh, it's saying that's not installed. All right, I'm not authenticated. Okay, is that login? Okay, let me do this one. I think because expired. Let me do like the login. Okay, continue. Just bear with me. But like what needs to happen is that like my credentials expired on Azure, and because I'm trying to leverage to retrieve an access token, that well, that didn't happen and it failed. So just let me get my subscription in place. I'm just having like another window where I'm retrieving or authenticating. And as soon as that's done, then we should have. But it's interesting with the core, right? You have control, but you don't necessarily know what's happened behind the scenes. That makes you more productive. Uh, okay, in theory, So now I am authenticated. I'm just load that up again. Cool. Let's run. Let's run. Loading, 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 execute. Okay. We should start seeing something coming here, like from the LLM. Okay, fingers crossed. Well, I'm hoping that things up. All right. Yeah, just having like some issues. Let me share my screen. Yeah, some interruption here, but now I'm back. So I was just like restarting this because I am authenticated, but it didn't load up. Let me close this. Not saving it. Yeah, well, this takes some time. Okay, fingers crossed. That doesn't come up. What I'm gonna do is to open a new Anaconda. I have like another prompt, but things are just really sluggish at the moment. Yeah, I think like I'm gonna, but take like a little bit time. That, yeah, completely unexpected. So yeah, to be honest, like with the things can take like a long time, and you're gonna see that on the ones I have executed. It took like some time, like minutes, to run the whole workflow. This one's supposed to be like just quick, a minute or so. In the meantime, while that loads, I have like the other example. Also, this is the source in here. You're gonna see that we have like towards. Yeah, somehow here this is complaining now. That's really uh, unexpected. So let me just authenticate. Okay, I'm getting like another screen. I think things just completely died in here on my machine. Okay, let's see. Yeah, do it again. I'm gonna leave it like running. Hopefully, like this one gets to trigger. And let's see the other one, the agents. This suppose well, this is much simpler when you look at what was implemented. A bit more. Uh, so what we have here is just loading variables and then getting bear token. So remember like those tools, the web search in here, what it does. I'm defining a tool that searches for web information. Search the web for information, but I'm not really exploring the web. I'm just returning a string, Autogen as a programming framework, blah, blah, blah. But we have this assistant, right? That is much more like straightforward than the previous implementation. I'm not providing methods. I'm not listening or printing anything. The only thing that I'm doing is that I'm hooking the LLM, that's the tool, which is the web search, and providing a prompt, a system message. And with that, I'm passing, okay, this is your task, find information on Autogen. If I get to load that up, so let's see. The other one, if because I have like just like a single subscription. It did, right? So it took like some time here, but it did. So on my end here, like authentication simply died. So I think my token expired and I need to re-authenticate. But anyways, it's in here. So when like that executed, so first we sent a message to this topic. We had like it brought up like the key features, so like eco-friendly design, stainless steel construction, slick and portable, and like yeah, the target audience, unique selling points. And then as it finished, it sends a message to the next topic. The writer said, well, create something. Say hello to your ultimate hydration companion design for the planet. Wow. And then the format proof agents make like things a little bit more smoother. And then printing things, or we can see like the rest in here in this editor. But what it's doing is that the format proof agents creates the final message and the user simply prints that, right? So you've seen that we have like a sequence in here and they came like uh, to work as expected. In here, I have like load that up. Let's do like this simple one in here. I'm using for this GPT 4.0 mini. It just does what needs to be done. And I was trying to vary and try different models. So load that up. I'm loading the tool, loading the assistant, and here we're going to start. I'm going to pull out the message, find information on AutoGen. And the assistant knows that it has its tools. The LLM is able to identify the tool and use it, right, on its benefit. So let's see. I'm just putting find information on Autogen. Let's see what the LLM finds. Well, it found came like Autogen is a programming framework. So it used the web search. We can see a little bit. Oops. Where? What other screen? Oh, I'm sharing like not the correct one. Let me remove and share the other screen. Just a minute. Share the screen. The entire screen. Let's see. Cool. Control plus. All right. So if you look, so what I was saying is that we have like this agent completion client. We're using GPT-4o Mini. We have the web search. Oops, Control Z. The assistant, which is a simplified version. So it's different from core entirely. We have like only that. And then we have, oh, that's the query, find information on Autogen. And when we look in here, so we can see that the query is coming with Autogen. We found, or it has like web search tool. And then we can see that function execution result. It used that, right? The name web search. It made like call, LLM made a call to the web search to retrieve that information. So that's pretty good. So it kind of knows its tools, right? With tools, you extend the capabilities of LLMs. Let's look like this other example here, Moat Agents Autogen. So what it does here is that it takes like a query. Well, we're talking about like the planner agents, planner for agents that do like planning of trips, local agents, language agents, travel summary agents. But what it's doing is just helping us, or it's assistant that can help plan trips. The other one is a local assistant that can suggest local activities. The other assistant is the language, or depending on the country you're going, you need like maybe language tips for giving the destination. You have like the agent that summarize things. One thing that's different is that we have the text termination. All right, so this is new. Uh, as part of the prompt, you can see like here that shows termination, terminate. As part of the prompt, I can say that, where is that? It's in here. When the plan is complete, when the plan is complete and all perspectives are integrated, you can respond with terminate. This is the cue for finishing the conversation. Another thing that it was introduced, round robin group chat. So the agent chat abstraction has these group chats. Round robin is just like a random way of agents coming and providing information. It's not like delegated. Simply like one comes based on the system prompts, it comes and provides the info. There are other ways when you can assign. You have like a selection, a selector agent that's going to associate. That's kind of the orchestrator that assigns a task to a particular agent. On this one, it's simply round robin. They're kind of just going through in a sequence, right? And this sequence is defining here: planner agent, local, then language, then travel. That's it. When there is like a selection, they can come and the orchestrator assigns the task to them individually. Let's run this. So we're gonna do like a trip. What's the plan? Plan a 3-day trip to Auckland. Okay. And what we're going to do, let's just load that up. And execute. We're gonna have similar sort of, well, in the end, like you're gonna see that all depends on the prompt, on the quality of the prompt. If you have like, if you don't provide boundaries, agents can go adrift, which they start like hallucinating or providing information that you don't want them to. But this one, I think they're gonna do well. And let's just look and see what they're gonna come up with. The first is going to be the planner agent. That was the user coming, plan a 3-day trip to Auckland. And then, yeah, like the planner came in the day one, morning, afternoon, or breakfast, a local cafe, or lunch at Viaduct, dinner at Brittle Mart, day two, nature, day trip to Rangi Total. So it's coming with those suggestions, right? I'm going to open this to be able to see more details. There's like local agents. So what sort of tips that they provide, it provides for like the city? Seems pretty much the same. Maybe like yeah, things like associated to suburbs, culture, and then we have the language agents saying that, yeah, learn like a few basic phrases in Maori. So it's coming with some recommendations, right? And then in the end, the summary agent that takes the best of all and puts like the plan, the, the day trip. And you can see here that it terminates, right? That's important. It means that the agents are going to be, well, the flow is going to be finished. And I said, like, depend on the quality of a prompt. Sometimes you see things happening, taking long time and not getting finalized. And that's a indicator that your prompt is missing something. So you need to provide more boundaries. So let's close that. I'm gonna save. Let's go like do some sort of coding. Looking like the timing here. Uh, the Magentic Surfer, right? The Magentic Surfer web surfer is a interesting implementation of Magentic One. So let's see. So you can see here that we're leveraging Magentic One group chat, and it uses also like a web surfer. So what it does with Magentic One is that I said like it handles file or web-based tasks. So you could say that, well, look at my disk and delete specific files, or take out my disk and create this sort of content. You're basically doing or delegating, or based on your prompt, tasks to be executed by Magentic One. What I'm doing here, I'm doing web data scraping. First of all, just initializing things, bring like the chats, OpenAI chats, like leveraging GPT 4.0. And then we have this modal web surfer, right? I'm gonna zoom in. It's a web surfer, meaning that it can connect to the internet, but we have no control on what they can do. When you look at the website, Autogen, there's like a big disclaimer that you need to do like this in a controlled environment because there are risks associated with this sort of execution, and you need to have control through prompting or even like a separate environment where if you're running this like on a company, like there are policies blocking that sort of firewalls or and yeah, any sort of suspicious activity that can be triggered, right? So this one is something that needs to be consideration. You're not going to simply be executing this organizations. But what I'm asking here is just how full are the Auckland dam levels? April 2025. What I did in here is that as of like today, I was trying to execute. It failed to run on the Python notebook. I noticed there was an open issue that's associated to that. So other people are facing issues with Python notebooks, but they said that if you don't leverage Python notebooks, if you leverage Python itself, it works. So what I did, I just created like a Python script, and I basically pulled that from the Python notebook to a Python code. And there's nothing different in here. The only thing is that this one takes a long time. When I say long time, it takes 20 minutes or so to execute. But if you look like what I'm gonna bring in here, right? So let me bring like this screen. And I had to execute this. And I executed this wow, like just by let's see here. So this was what I put it, right? So Python, Magentic Web Surfer, Py, and trigger that. And that was my user query. How full are the Auckland Dam levels? April 2025. And then you can see like the orchestrator, the Magentic One orchestrator coming that we're working to address the following user request. And like to answer this request, we have assembled the following team, well, the web surfer, right? So it's assembling that and bringing some facts for consideration for the web surfer to be able to extract the information. Current Auckland dam levels. I check like maybe historical average dam levels. And yeah, educated guesses like that. They're gonna look like the network of dams in like in Auckland. So just providing some sort of input for the query to be made. And then we see like the orchestrator say, please search for the current Auckland dam levels of April using credible source. That's it. And then the web surfer goes wild. I typed Auckland dam levels April 2025. And then it comes like from Bing, right? So there is an output. So it's basically doing data scraping at this stage, grabbing whatever comes there, like sources, right? Water levels, different like links, even like tags. And then the orchestrator says, click on link, silver lining, Easter rain likely to boost Auckland dam levels. So just going down there, and then the agent, the surfer saying, I clicked this, going down, right? And trying to find information, I asked. But then like saying, well, look, the orchestrator, please summarize the web page, focusing on Auckland dam levels, any relevant context. So the surfer is trying to extract the information from the first source it got, but it wasn't successful, really. Like it's just, you can see like the orchestrator saying, search for detailed statistics, specific figures, still going through that. But then it got to a point that, oh, I typed this, didn't find, or there wasn't a percentage. How full are the dam levels? And then going there, it says, well, try the other one, like other link. And then like, yeah, I click this. And then it gets like the data information. It, it goes like onto that, but it finds that, okay, average 73, but contributed, uh, okay, but there was like an answer. The total, okay, as of April 21st, the total water storage across 64.88%. Then there was an error. Things in here I got What was that? 4 to 9. Yeah, I got like an error in here that, yeah, 4 to 9 rate limits exceeded. So he tried, but he got like to the point that he did that. It took like 20 or minutes or so. So it can take some time. I think that's being patient that things are going to be triggered and they're going to execute really. The other one I had it in here was this dev teams agent. So this is an interesting one. So it's leveraging GPT 4.0, but it has like these tools available. Different tools for reading, if I read operations, read writing, and I provide like you need to provide some sort of definition or a detail for that or of what it does. And then like you can list like listing all files, deleting files, and then just have like this tool, super tools, or defining a developer, a tester, and a technical lead. So, well, the developer, your final answer must include Python code implementing the solution. The tester, running and writing and running test cases. Technical leads must challenge the code and provide constructive feedback. Create markdown documentation. Delete files that are not of any use. Create the requirements text. If you're happy, respond with finish. This is important. So you need to provide that and well, you need to control. If you don't do that, execution is going to continue. You're going to be paying for tokens. Yeah, that's important. So we have a termination. But what I'm asking here is that there's a folder called .NET 8 Web API project, contains .NET application, create a fast API template project. This is Python. But as soon as I do that, this one took 15 minutes or so. But what it does is that I think like there was the main prompt. You can see the developer, right? So it's just organizing. It looks. So it was looking at this code. Actually, like it got deleted. So the agents, as you're gonna see, it deleted that. This was the original code. So we had like a controller, a model, right? Basically, I put that separately just for the agents to do the work, and it converted to a Python uh, implementation. Even like creating documentation for that. I said like the README. Right? Yeah. And it did that. It create tests as well. Right? Routers in here, like the different routes, the models, creates the requirements. So like it did the work, but when you look like what it printed, so you see the rationale like behind and the different interactions. So maybe if I think I have it here, the text editor. Generally, the text editor contains like all those details. So this is the developer. Just saying it contains this. I'll begin migrating to Python. Then start doing that. You can see that's using like those tools. Directory has been created successfully. So it was creating those directories in here, creating models. Then the testers coming here, it creating, or it checked that those were already in place. There's been like the technical leads coming here, doing some sort of hooks, like the main .py, the developer coming and populating like the router for that, and the technical lead looking at the model and developer creating that written successfully. So it incrementally, well, things are continuing. So it's just taking here, like let me assess the controller logic. That was the technical leads. So just saying, look, this is what we have. And the developer coming, oh yeah, it has been closely followed. So they're the agents are talking to each other. Uh, this is interesting, right? So you can see like where things are okay. Yeah, the project has been created successfully, blah blah blah. It gets to a point where yeah, they're kind of coming back and forth, and then like technical leads coming here, writing the README, and the testers coming, yeah, validating, okay, requirements text is there. They're I'd say they are kind of stepping each other's shoes. They're kind of stretching a little bit the boundaries. That's why like the system prompts is important. But I could see in here that it wasn't perfect. Like even like the tester in here like is like suggesting things that go like beyond what it could do. But in the end, they turned okay. All right, but as we're gonna see, like so this one like technically deleting the files, and then it just deleted that the original sample, um, and where things are getting to the uh, final imp- details in here implementation. Like then like there was conversation could be like going adrift, like let's execute, like set up a test environment. They're like, oh, that's not gonna do it. Uh, it doesn't have access to those um tools, right? Like or executables, nothing like that. So it was going in another direction. But when you see like things like that, so you could just come with another prompt and say, look, don't suggest running this live at all. Right? So you could provide like more prompts with that. And then when it gets to here, like okay, you've developer talking, you've outlined a solid plan and back and forth, finalizing. So there's a little bit more conversation until the technical lead finishes. This took like more than 20 minutes, right? So what you're gonna see is that you're gonna be able to run those yourself. I have like the Python code. This is the same implementation, uh, but like leveraging. Oh, that's more like organized, different agents, right? So like software, you can run this one. It's going to do like the work. This was in Python notebook. This is Python codes directly, right? So just running uh, the code for that. Um, yeah, so you'll be able to run it, but you're gonna see that it can take some time, depending on how complex or the level of back and forth for things to be finalized. Yeah, it can take some time, 15 minutes, something like that. But it's good, like because you can simply validate and prototype things faster with minimal code. And that's like the agent chat. Not sure if you have like any questions. We just went a little bit beyond. We had like a little bit of hiccups. One of those things, right? That if you are like watching, uh, if you want to win those uh, JetBrain licenses, I suggest you just to put a message on the meetup. So we have like a meetup, and if you're not part of that, I invite you to join like the user group. Let me just put like the link so you can connect yourself and join the user group. So let me just put in there. I'm gonna put on the chat. So if you want to win a license, right, a 12-month personal subscription, just put a message in there. So this is the meetup. Join and go like through the session, right, so that we have for today, and put like a message in there. Please, I'd like a license, and then that's it. The license is yours. I have like only 2 available, so first comers, first takers, and yeah, that's it for today. I hope like you could learn like a little bit more about the Autogen framework. Check like the source codes. They are uh, going to provide like uh, as a quick starter for you to get to play, and you can tweak and modify like for your own use cases, right? So with that, like I appreciate like you staying with me up to the end. And next month, so Tassina, yeah, please just join there and put like a message, as I said, within the Code Night session, a New Zealand session, because then I can provide you with the license and we can talk like later in how I'm going to send you like the license number. And but like next month, we're going to have Global Azure. So that's coming and it's happening in person on May 8th. And that's going to be happening on Thursday at Microsoft Auckland. And on Saturday, we're going to have a full online day, a full day of online sessions, speakers of wow, from different countries. And it's going to be fun. Uh, I invite you to join and to check like the sessions. It's always great like connecting to people. We have like this like on Thursday that's happening. We're coming in person. So that session is happening at the Microsoft Auckland, New Zealand, and we're gonna have like different sessions happening. And you can check like the ones we're having like on globalazure.net/sessions. Right. With that, yeah, I'd like to thank you for staying up to this time. And well, talk to you guys next month on Global Azure. Yeah. Cheers. Catch you guys soon.